Hi everyone, I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. Today in this video I am going to explain about some of the manufacturing methods and description of the interfacial bonding. So the topics in today's class are the last one in the manufacturing method, that is the injection molding, and second topic is the interfacial bonding. So in the interfacial bonding we are going to discuss about the phase structures and types of interfacial bonding, and what are the structures we are going to see in the bonding. So that is the primary, secondary, and this is my 16th lecture in this advanced materials subject. So in the earlier classes or lectures we have already discussed about the different types of manufacturing methods: the hand layup, spray layup, spray up, filament winding, pultrusion, RTM, that is resin transfer molding, and autoclave. We have already also discussed about one of the molding method, that is prepreg. And in the molding method there is another method also known as injection molding. So this method is going to discuss in this class, and last one is the interfacial bonding. So let's see about the last method of the manufacturing method. So coming to the injection molding process, this injection molding process is a closed mold process in which this molten polymer, that is heated polymer, so molten means heated, that is now commonly used is thermoplastic resin, and this is mixed with very short reinforced fibers. So different types of fibers have been used in the reinforcement: long fibers, medium fibers, and short fibers. But here we are using the very short reinforced fibers which is chopped by a cutter. That is, we are using 10 to 40% of the reinforcement is forced under high pressure into a mold cavity through an opening, that is known as the sprue. So sprue is the opening of the mold cavity which we are going to pour the short reinforced fibers, which is chopped fiber, the chopped, which are known as chopped fibers. So commonly we are using the thermoplastic resins here as compared to thermosetting resins. Thermoplastic resins have been used in the recycle process also. So there we can use multi times. Next one is the polymer fiber mixture in form of pellets is used into an injection molding machine through a hopper. Hopper is a opening type of chamber, and the material is then conveyed forward by a feeding screw and forced into a split mold. So there we are using the split mold sections. So split mold means two types of section have been there: upper die and the lower die. So and these are forced into the split mold, filling its cavity through a feeding system with sprue gate and runners. So these are all the different types of parts in the open mold closed mold cavity, which we are already seen in the production technology subject. So in the production technology subjects, different types of patterns have been used. It is one of the pattern, that is the closed pattern, split piece pattern. So a split piece pattern have been used here, that is the upper die and the lower die. And the screw of the injection molding machine is called as reciprocating screw, since it does not only rotates but also moves forward and backward according to the steps of the molding cycle. Then it can generate a ram, and it acts as a ram in the filling step when the molten fibers are mixed in the injection molding, and then it retracts backward in the molding step also. So when we are going to filling the with the ram, the molten polymer fibers are mixed in the injection molding chamber, and then it is going backward in the molding step, and then it mixes it with the resin. Then the heating elements placed over the barrel and is soften and melt the polymers. So when we are going to see it in the low amount of heat also, the polymers can melt and soften. At last, the mold is equipped with a cooling system providing controlled cooling and solidification of the material. So different types of solidification process are there in the manufacturing methods. So we are doing the cheapest one, that is the cheapest one and the shortest one. So this is the injection molding diagram. So here we can see the different short fibers used in the hopper. It is known as pellets. So short fibers is named as pellets here. Then it is sent to the through the hopper, which is an opening gate to the closed mold, and from there it passes through the heat screw and heaters, and through the barrel it comes to the nozzle, and then it comes to the screw, which is the opening end of the split mold. You can see it in the red color, and pin and ejectors are there to split the mold when the mold cavity is cured and ready to open. So when the mold cavity is ready to open, we use to push the ejector pins. So then the mold is going to split and open. So this is the basic parts of the injection molding system. Look it for a while. So next, the polymer is then held into the mold until solidification. Solidification means when the molten metal is converted from the liquid state to the solid state, that is on the harder part of the region, and then the mold opens and the part is removed from the mold by ejector pins. So these we have already seen in the last picture that two ejector pins are there in the split mold. We can see it in the right side mold. So when the ejector pins are pushed out, the mold is split into two pieces, and the mold cavity is separated from the die, and the part is removed from the mold by ejector pins. Then injection molding is used mainly for thermoplastic matrices, but these thermoplastic matrices are also may be extruded. Extruded means pulled from the original part from the both ends. Then in this case, curing occurs during heating and melting of the material in the heated barrel. And this is cross-linked structure. And a principal scheme of the injection molding machine is shown in the picture. A principal scheme of an injection molding machine is shown in the picture, and the injection molding is a highly productive method which provides high accuracy and control of shape for the manufactured parts. So in this method we can obtain the high accuracy, and this method is profitable in mass production of large number of identical parts. So this is profitable in mass production where we can produce only one type of product in multiple times. So a large number of single identical parts can be produced in the mass production. And one of the disadvantages of this method is limited length of fibers decreasing their reinforcing effect, which means we are using these short fibers only. So we are using very short fibers here, but in the earlier processes of the manufacturing methods we have used the long fibers there. So long fibers have been used in the earlier methods, but in this method the length of the fibers have been shortened in the reinforcement. So this is the injection molding machine. So 3D view of the injection molding machine. Here you can see the different parts of the injection molding machine. So first there is a clamping motor drive which is attached to the clamping bar, and a rear plate is observed in between the clamping motor drive and clamping bar. In the bottom you can see the ejector bar where you can open the bar, and the ejection system and the molded part. So the process will be started from the right side of the picture, that is from the right side of the view. You can see the hopper in the black color. So it is a raw plastic which is sent through the hopper, and this is running through the screw motor drive which is attached to the solid shaft of the molten plastic, and you can see the molten plastic in the red color, and it is sent to the barrel and then to the mold cavity, mold core. So heaters have been used in the intermediate position of the barrel, which is used to reduce the solidification process. So the molten metal is used to carry the liquid in the mold cavity only through the mold core. There you can see it in the brown color. So from the nozzle, the molten metal enters to the mold core, and a mold cavity is produced in the stationary platen. And when the ejector pins are ejected, the mold cavity is opened from the die, that is removed from the die. So look it for a while. So this is about the injection molding method, and you can see the injection molding machine in this picture also, and the process is started from the right side of the picture, so that is from the hopper. So these are the different kinds of manufacturing methods used to manufacture the fiber reinforced composites. So these injection moldings come under the molding method. And the Last topic to be delivered in this unit is the interfacial bonding. So between the matrix phase and dispersed phase, a good bonding should be provided to transfer the load and the applied to the material to the dispersed phase via the interface. Interface means the opening area of the topmost surface of the material is known as the interface, which we have shown in the as the bonding structure, and this interface should be applied to the material to the dispersed phase via the interface, and adhesion is necessary for achieving high level of mechanical properties of the composite. Adhesion means bonding, that is known as the good bonding, which is used as the gum here. సో అతికించడానికి అన్నట్లు. సో అడిషన్ అంటే అతుక్కోవడం మనం. సో దాన్నే గుడ్ బాండింగ్ అంటున్నాం ఇక్కడ. సో దేర్ ఆర్ త్రీ ఫార్మ్స్ ఆఫ్ ఇంటర్ఫేస్ బిట్వీన్ ది టూ ఫేసెస్. సో టూ ఫేసెస్ మీన్స్ matrix phase, reinforcement phase. So there are two types of phases which we have discussed in the introduction part of the advanced materials. First one is the matrix phase, second one is the dispersed phase or reinforcement phase. So there are three forms of interface between these two phases, that is the matrix phase as well as reinforcement phase. Direct bonding with no intermediate layer. So first one is the direct bonding with no intermediate layer. So in this case, adhesion is provided by either covalent bonding or van der Waals force. So we have already discussed in the earlier lectures that types of bonding. So there is ionic bonding, metallic bonding, covalent bonding, and last one is the van der Waals force. So here we are using it in the direct bonding, that with no intermediate layer. We are using the covalent bonding here, which is very strong bonding in the chemical bonding. Second one is the intermediate layer, is in the form of solid solution of the matrix and dispersed phases constituents. So it is in the form of solid solution of the matrix and it can be dispersed in the reinforcement phase. So that is the second type. And last one is the intermediate layer, is in the form of a third bonding phase, that is known as adhesive phase. So it is also called as adhesive phase. So in this, the intermediate layer is in the form of a third bonding phase, but in the second type it is known as the interface, and first one is it is known as wetting phase. So these are the three forms of interface between the two phases which we have been observed. Next one is the interface. So there is always an interface between the constant phases in a composite material. So that is the matrix phase and the reinforced phase. And for the composite to operate effectively, the phases must bond where they can join at the interface only. So here in the picture you can see the different types of phases observed. So there is a dark circle that is known as the secondary phase, which is the reinforced phase, and here we are using the fibers as reinforcements, and pale brownish color is the matrix phase, that is the primary phase, and the interface between the primary and secondary bonding is known as, that means the boundary between the primary and secondary phases is known as the interface. So that is the meaning of interface. So there is always an constant phases in a composite material, that is in the between the primary phase and secondary phase. Here we are seeing the only a cross section of the interface only, but in the real picture there are so many amounts of secondary phases, and the gap is the primary phase, that is the matrix phase. So matrix phase is called as vacuum there, and the grains containing different types of bondings is known as the reinforcement phase. And in the reinforcement phase we are using the fibers as reinforcements, that is short or large fibers, that is used as the reinforcement phase. Next one is the reinforcement matrix interface. So what is the main concept of the reinforcement matrix phase? That is the primary and secondary phases. So the bonding between the primary and secondary phase. So the load acting on the matrix has to be transferred to the reinforcement via interface. So in the earlier picture we have already seen that the bonding between, or the boundary between the primary phase and secondary phase is the interface there. Then the reinforcement must be strongly bonded to the matrix if high stiffness and strength are desired in the composite materials. So in the composite we are going to define the new properties from the new materials by combining the two or more materials combined to form a composite material. So in the reinforcement we are using the different kinds of materials or metals to compose the high stiffness and high strength, so that we are desired. So these we are going to desired properties in the composite materials. And a weak interface results in the low stiffness and strength but high resistance to the fracture. So these interface results in the low stiffness and low strength, but it also has the high resistance to fracture. So when we have applied a sudden loads on the material, it resists, but it resists and it has high resistance to the fracture also. Generally, a strong interface produces high stiffness and high strength to, but often low resistance to the fracture. That is known as the brittle nature. It is also known as brittle behavior of the properties. So if it has low resistance to the fracture, it is known as the brittle behavior. So that is the strong interface. But a weak interface results in the low stiffness and strength but high resistance to the fracture. So these are the types of interfaces between the bonding section. Next one is the two types of failure at the interface. First one is the adhesive failure, second one is the cohesive failure. So in the adhesive failure, the failure occurs at the interface, but when coming to the cohesive failure, the failure occurs close to the interface but never in the interface, never in the interface. But in the adhesive failure, failures occurs only at the interface only. That is the bonding between the primary phase and secondary phase. Next one is the types of interfacial bonding at interface. So we have already seen the different types of failure at the interfacial bonding. Next we are going to define the classification of the interfacial bonding at interface. So there are mainly three types of bondings occurs at the interfacial bonding at interface. So first one is the mechanical bonding, second one is the physical bonding, and third one is the chemical bonding. So these three are the different types of bonding which occurs at the interface of the interfacial bonding. So in that classification, in the types, first one is the mechanical bonding. So in the right side picture you can clearly see the layer of the interfacial bonding. So left side one is the matrix and right side one is the reinforcement. So matrix is seen in the dark color, and reinforcement is seen in the pale light color, that is the pale color, light color. So in this, fiber is used as the reinforcement here, and matrix is which we are used the core material only. The difference gap between these is known as the interfacial bonding, and it is also known as the interface. So in the mechanical bonding, it is a simple mechanical keying or interlocking effect between the fiber matrix phases. So different types of fiber matrix phases have been used. So fiber is the reinforcement and matrix is the phase here. So when the matrix shrinks radially on cooling over the reinforcement, which leads to a gripping action of the matrix on the fiber. So when this is in the when the process is on the solidification, the liquid is converting it into the liquid is converting into solid bonds, and the reinforcement leads to the gripping action of matrix on the fiber, which is on the cooling structure. So when it is taking the temperature from the high temperature to the room temperature, so when it comes to the room temperature, it is cooling and cured. So that is in the mechanical bonding structure. Second one is the physical bonding. So in this kind of bonding, it involves weak or secondary or van der Waals forces, which is at the dipolar interactions and hydrogen bonds. So in the physical bonding, there is the direct involvement of interfacial bonding in the interface section, which is at the weaker side, that is on the secondary bond. And in the secondary bonds, hydrogen bonds are highly used in the secondary bonds on van der Waals forces. Next, these types of bonding mechanism is of low significance because of its low magnitude. So it consists of the low magnitude structure. So because of its low magnitude, it is of the low significance. Last one is the bond energy lies in range of 8 to 16 kilojoules per molarity. That is 8 to 16 kilojoules have been used in the bond energy. So that is in the physical bonding, which we are using these hydrogen bonds on the van der Waals forces. And last one is the chemical bonding. So this chemical bonding consists of two types of bonding. First one is the dissolution bonding, and second one is the reaction bonding. In the dissolution bonding, the bonding is of short range and it is less used and occurs at an electronic scale. And this type of bonding is hindered by the presence of impurities. Hindered means showing on the fiber surface, and also gas or air bubbles are at the interface, which is going to oxidize it in the surface layer. This is the first type of bonding. So in the dissolution bonding, there is a disadvantage, which it gets deoxidized in the surface layer, and the surface have been used to going to fractured, that is on the failure section only. But when it comes to reaction bonding, this bonding is due to the transport of molecules, atoms or ions, which diffuses to the interface. In the below picture, you can see the interface bonding, interfacial bonding. So M defines the metals, that is the matrix, and F defines the fibers, and in between that interface is in between the metal and fiber, which is used the solid solutions and intermetallics. So the crossed lines have been used as the intermetallics, and the dotted lines is the solid solution used. So this is the basic difference between the mechanical bonding and the chemical bonding. So in the chemical bonding, reactions have been observed in the endings of the boundaries, that is on the matrix phase as well as the reinforcement phase. But in the mechanical bonding, it is combined in the structure only. So that is the basic difference between the mechanical bonding and the chemical bonding. So here we are using the fibers as reinforcement. So fibers have been widely used as the reinforcement in the fiber reinforced composites. Here we can see the different kind of interface here. So in the earlier interface, we have seen only the primary phase and the secondary phase. On the top of the secondary phase, there observes the interface, but here interface structure is separately shown. So in this interface, in some cases, a third ingredient must be added to achieve bonding of primary and secondary phases. So in between that, a catalyst have been used to well composure of the fiber and the resin, that is the reinforcement and the matrix. In the earlier manufacturing methods, we have seen that a separate catalyst have been used in the mixed chamber to mix the reinforcement, that is the fibers, and as well as the resin, that is in the liquid form. There is no amount of chemicals added, no amount of chemical reactions observed on the manufacturing method. So to reduce the chemical reaction, we are using this catalyst, which is well, it is going to mix the resin and the reinforcement. So here we can see the darkish color as the secondary matrix, secondary phase, that is the reinforcement phase, which we are adding the fibers as reinforcement, and the interface is on the topmost of the layer of the secondary phase, which is thick in color, that is the we are adding the catalyst as third ingredient here, and the primary phase is on the topmost and remaining part is the primary phase. So sometimes it is called as interface, which is composition of the third gradient, and this can be thought of as an adhesive also. So which is the composure of different types of bondings. So there we are using the third ingredient as adhesive. So in the picture you can clearly see the composure here in the third ingredient interface. In the third ingredient interface, you can clearly observe the difference from the natural interface. So in the natural interface, only two types of phases have been directly observed, two ingredients have been directly observed, but in these types of interface, three ingredients have been widely used, that is the primary phase, secondary phase, and third one is the interface. And this is another types of interface, and this interface consisting of a solution of primary and secondary phases only, and the third interface is the solution of primary and secondary phases only, which is a mixture of the primary and secondary phases only. So in the picture you can see clearly see the difference. So this is the cross section of the bonding structure, which is seen in the fiber reinforced composites. So the gap between the secondary phase is known as the primary matrix, that is the matrix phase, and the gap between primary phase and secondary phase is known as the interface, that is also the solution of primary and secondary phases. But here we are not using any third ingredient here. We are only mixing the primary phase and secondary phase, that is matrix and reinforcement phase only. So by combining these two sections, that is the primary phase and secondary phase, we are going to obtain good stiffness and good strength due to high desired properties. So we can obtain our desired properties in these sections by mixing the third ingredient as solution of the primary and secondary phases, and the third ingredient here using it is known as interface. But in the earlier interfaces we have seen the third ingredient as catalyst, and in the first interface we are not using any different kind of third ingredient, and the boundary between the primary and secondary phase is known as directory and interface. So this is the basic difference between these three interfaces. So first one is the contains only primary and secondary phase. The boundary between the primary and secondary phase is known as the interface. But in the second type, a third ingredient is used as a catalyst, and this is the basic boundary of these two sections, that is primary and secondary phase. And last, in the coming to the last interface, there consists of an interface that is the combination of primary and secondary phases, that is the solution of primary and secondary phases. So these are the different types of interfaces which we can observe in the interfacial bonding. So interfacial bonding plays an important role in the combination of reinforcements and reinforcement in the matrix phases. So by repelling these reinforcements from the matrix, the material leads to the failure only. So we have to access these types of interfaces in the matrix and reinforcement phases also. So this is the basic function of the materials or process which we are doing it in the research and development process only. So in the universities, they are the students or the lectures we are used to be developed all these structures. So they are developing these type of structures from day to day, and they are going to research new type of material. So this is the new type of interface here. So we have already defined the different types of new materials, but here we are defining the different types of new interfaces here. So that is the basic difference. So by applying these different types of interfaces, we can obtain different types of desired properties in the same material. So by using different types of material interfaces. So first one, second one, and third one. But in the common element in these three interfaces are the primary and the secondary phases. So the difference is the third ingredient in the second types of interface. But in the last interface, that is the combination of, that is the solution of primary and secondary phase only. So by here I am ending this topic, and this is the end of this unit also in the advanced materials subject. Thank you.